All right, so our video today is on, once again, Unit 7, and we are looking at the concept of nonlinear systems today. And so mostly, actually, all of these are quadratics, so something with an x squared, and linear systems. So the first one is an inequality, and these three are once again taken off your last assessment. So if you're interested in retaking your last assessment, that's why I'm going through some of these problems. So when I'm solving a system of inequalities, this is going to be a whole set of ordered pairs, and so we represent this with a graph. So I'm going to go ahead and graph x squared minus 8, which is a parabola opening up with vertex negative 8. Of course, you can use your graphing calculator to help you with some sketches of graphs, but I knew this just because of the graph translation theorem that x squared is a parabola centered with a vertex of 0, 0, minus 8 bumps it down 8. And I could graph some points, meaning going over 1, up 1, because 1 squared is 1. And I could go over 2, up 4, if I wanted some other points on the graph. But we have a parabola. That parabola is a solid region because of the less than or equal. And then I'm going to test the point 0, 0 to see where I shade. So 0, 0 you can see is if this parabola would continue up kind of inside or on the interior. If 0, 0 is not a solution, I'm going to shade on the exterior. So I check 0, 0, and I get 0 is less than or equal to negative 8. And 0 is not less than or equal to negative 8. That's false. And so I'm going to be shading on the exterior of this. All right, and so then I graph this line. So for those of you who like to change things to slope-intercept form, if I did that, I would have negative 1 is less than negative x plus 1. But I would have to divide both sides by a negative 1, and when I do that, in an inequality, I have to flip, so make sure we're flipping that sign around. So this line has a y-intercept of negative 1 and a slope of 1. It is a dashed line. Okay, so I test again the point 0, 0. 0 and 0 is greater than negative 1. That's true. So 0, 0 means I'm going to be shading like above this line and outside the parabola. So if I wanted to stay above the line, that would be up here, but then outside the parabola. So the region is over here and over here. And I could just take away this part because that is not a solution set for the bottom line. Okay, the second two examples are the linear and quadratic equations, systems of equations. And so I'm going to go ahead, and the question says if the ordered pair xy satisfies the system of the equations, what is one possible value of x? When you're solving a linear and quadratic, it is possible that there are two solutions. So I'm just asking for one possibility. I'm going to go ahead, and since y is equal to 4 minus x, I'm going to take the y out here, and I'm going to put 4 minus x in its spot. I am going to solve the quadratic by getting 0 on the side, so I'm going to subtract 4 and add x. And I get 0 equals x squared minus 3x. The 4's cancel, so I'm going to solve this by factoring. So pulling out a common factor. And my solutions for x are x equals 0. If I wanted to find y, I would plug it back in. I didn't ask you to do that, so I'm not going to. And x equals 3. So either of those would be possible answers. And finally, the last example that we're gonna look at was a little more complex. Some of us struggled with this one. It says if x, y is a solution to the system of equations and y is greater than 0, what is the value of y? And so I think the very first thing that I'm gonna do is I am going to take this y up here, and since there's a y down there, I'm gonna go ahead and subtract 3x from both sides, which gives me y equals -3 minus 3x. I'm then going to put that down here. So what that leaves me with is on this side, x plus 1 squared minus 4x plus 1 minus 6 equals -3 minus 3x. I'm going to expand this, so many of you, I gotta move that over again, I think. Hold on. All right, so many of you expanded this incorrectly. And so x plus 1 squared actually means x plus 1 times x plus 1. And this would mean minus 4, parentheses, x plus 1 minus 6. Okay, so I'm gonna go ahead, I'm gonna rewrite this down here since I'm struggling a little bit to get the camera to show up. So x plus 1 times x plus 1 is x squared plus 2x plus 1. When I distribute this, I get minus 4x minus 4 minus 6 equals -3 minus 3x. Moving the left over to the right, I have x squared. When I add 3x to both sides, that gives me plus, oops, sorry. I have to add like terms. So I have 2x minus 4x, and then I add the 3x to the other side. So that is gonna give me plus 1x. 1 minus 4 minus 3 is, let's see, -3 minus -9, and then I add the 6 to both sides. Okay. So once again, this step you can go slower and show more work, but I added like terms over here, and then I moved the things from the left to the right. Move the things from the right to the left. Okay, so how do I find x then? So we have x has to multiply to be -6, add up to 1. So x plus 3, x minus 2 equals 0, which leaves me with x equals -3, x equals 2. Remember up here, we had an equation to solve and find y. And so if I plugged x is -3 in here, I would get -3 minus 3 times -3, which is -3 plus 9. -3 plus 9 is 6. And so that would be one of the answers for the value of y, because that's when y is greater than 0. If you plug in x equals 2, what we get is a negative answer. So -3 minus 6, which is -9. So this is the answer we should have found. Definitely a lot of more work in that one than some of the other problems. All right, so I have a few, I believe 2 or 3 quadratic linear systems and systems of inequality for you to try for your next assignment.